We are going to continue the topic circle, lecture number 5. Okay. Yesterday we were discussing about pole and polar. So let us take the discussion once again. What is the definition of pole? It is the locus of the, if you take a circle, if you take a fixed line, the chords of contact of points on this line with respect to this circle will be concurrent, and that point of concurrence is called pole. See, these two chords of contact intersect at one point, and if you take any other point and draw the chord of contact like this, this chord of contact also passes through the same intersection point. Okay. So, this point is called pole and this fixed line is called polar. In the same way, we can also construct the polar using the pole. If you take a circle, take any point P as pole. Through the pole, you draw chords, different chords. Then draw the tangents at the ends of each chord. This is the intersection point of these two tangents at the ends of this chord. Similarly, if you draw tangents at the ends of this chord, they will intersect at one point. Again, draw the tangents at the ends of this chord, and these 3 points will be collinear. The diagram is not correct. If you draw properly, then the points of intersection of the tangents at the extremities of chords passing through the fixed point will be collinear, and this line is called polar. Okay. Now, yesterday we discussed the formula too. What is the formula? So, the definition is the chords of contact of points on a fixed line with respect to a circle pass through a fixed point. It is called pole, and that fixed line is called polar. Okay. Similarly, let us discuss the important points. The equation of the polar of the point P x1 y1 with respect to the circle S is equal to 0 is given by S1 is equal to 0. Let us prove it. Take one circle and take pole P x1 y1. What is the definition of polar? It is the locus of the point of intersection of tangents drawn at the extremities of chord passing through A, passing through P. Consider a variable chord AB passing through P. Now, if the tangents at A and B intersect at say Q, then we want the locus of Q. We have already discussed that the path of Q will be a straight line, and that straight line is called polar. Now, let us take Q as x2 y2. Now, we are going to find the locus of Q. Okay. First, let the circle be S is equal to 0, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay. Now, AB is a chord passing through P, tangents at A and B intersect at Q. Now, the line AB will be the chord of contact of Q. Yesterday we have already discussed. How to get the equation of the chord of contact of a given point? We have discussed the formula S1 is equal to 0, but the point here is x2 y2. So, the chord of contact of Q with respect to this circle will be S2 is equal to 0, because the point is x2 y2. Okay. So, equation of the chord of contact of Q x2 y2 is S2 is equal to 0, is it not? What is S2 is equal to 0? X2 plus y2 plus G into x plus x2 plus f into y plus y2 plus c is equal to 0. It is nothing but equation of AB. Now, it passes through Px1 y1. If it passes through Px1 y1, then by substituting P in this equation, you will get x1 x2 plus y1 y2 plus G into x1 plus x2 plus f into y1 plus y2 plus c is equal to 0, right. Now, by observing this condition, can we tell the locus of Q? After getting the condition, what should we do? If you want the locus of x2 y2, you should replace x2 by x and y2 by y. So, if you replace x2 by x and y2 by y, this equation becomes the locus of Q. Therefore, the locus of Q is, replace x2 by x and y2 by y, x1x you can write as xx1, this is y1 y, we can write as y1 plus G into x1 plus x or x plus x1. Similarly, plus f into y plus y1 plus c is equal to 0. Okay. The locus of Q is nothing but the equation of the polar, is it not? So, what is the equation of the polar? According to notation, this is S1 is equal to 0. Okay. In the last step we got the equation we got was S1 is equal to 0. So, that is the equation of the polar of the point Px1 y1 with respect to the circle S is equal to 0. Okay. Now, this S1 is equal to 0 is a formula for equation of the tangent. It is also formula for equation of the chord of contact. What does it mean? Suppose there is a point on the circle, then what is the equation of the tangent at P? equation of the tangent at P is given by S1 is equal to 0. And what is the polar of P? S1 is equal to 0. That means when the pole lies on the circle, the polar coincides with the tangent at the pole. Okay. Similarly, if you take a point outside the circle, then we discussed that and proved that the equation of the chord of contact of P, equation of this line is S1 is equal to 0. Now, the equation of the polar is S1 is equal to 0. So, when the pole is outside the circle, the polar is nothing but the chord of contact. Okay. Now, when P is inside, then polar will be a non-intersecting line. Okay. So, remember these points, that when P is on the circle, polar is nothing but tangent, and when P is outside the circle, polar is nothing but chord of contact. When P is inside, the polar is some non-intersecting line. Now, another point is, the polar is always perpendicular to the line joining the center and the pole in all the cases. Here this is the center. If you join C and P, the polar will be perpendicular to the line joining pole and the center. Here also, we know that tangent is perpendicular to PC. Okay. But how can you tell that in this case? If you take the equation S1 is equal to 0, xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. Okay. Now, we can write this as x1 plus g into x, equation of the polar, plus y1 plus f into y plus remaining terms gx1 plus fy1 plus c is equal to 0. Okay. What is the slope of the straight line? Slope of the straight line is minus of coefficient of x by coefficient of y. Coefficient of x is x1 plus g by coefficient of y is y1 plus f. Now, what is the center of the circle? Minus g minus f. Center of the circle S is equal to 0. And what is the point P? x1 y1. What is the slope of PC? It is y1 plus f upon x1 plus g, slope of PC. And observe that this into this is minus 1. Therefore, this polar is a line perpendicular to the line joining the center and the pole in all the cases. Okay. So, overall you can visualize the position of the polar with respect to the pole. Suppose circle is like this. This is center. See, if I take pole here, then the polar is chord of contact. You will get some line like this. If you move pole towards the center of the circle, then the chord of contact will just move away from the center. So, when P is moving like this, polar will be moving away from the center. Finally, when P comes on to the circle, when P is here, the polar coincides with tangent at the pole. When P goes inside further in the same direction, then the polar will come outside. So, when P is moving still like this in this direction towards the center, polar will be moving away from the center, right. Finally, what happens when P reaches C, center? This polar, when P is very close to center, polar will be very far from the circle. When P coincides with C, the polar disappears. That means center of the circle has no polar. Okay. When P further moves like this, polar will appear that side, far away from the circle. When P is moving, polar will be moving towards the center of the circle. When P comes onto the circle like this, polar becomes tangent. When P further moves, polar will move inside. Okay. So, this is the visualization of pole and polar. So, important point is center of the circle has no polar. We can also discuss that point in another way. Why the center of a circle has no polar? Take pole here. What is the definition of, how do you get polar? You have to draw different chords passing through P. Then you have to draw tangents at the extremities of each chord. Okay. And these tangents intersect on a fixed line. This line is called polar. The locus of the point of intersection of tangents drawn at the extremities of locus of the point of intersection of the tangents drawn at the extremities of chords passing through a fixed point is a straight line. That straight line is called polar. Okay. Now, if you take center of the circle as pole, then if you try to construct the polar, what happens? You should take different chords through the center. Okay. Then you draw tangents at ends of each chord. If you draw tangents at the extremities of diameter, they will be parallel, they will not intersect. Okay. That is why there will be no locus of the point of intersection of the tangents in this case when C is the pole. Okay. That is why the center of a circle has no polar. Okay. Similarly, any line passing through the center which is called diameter will have no pole. Let us see how. Any circle passing through the center, any line passing through the center will have no pole. Okay. Why? In the general case, if polar is given, how do you get the pole? You should draw tangents from points on this line, then draw the chords of contact, and these chords of contact intersect at a fixed point. This fixed point is called pole. Now, if you take a line through the center like this, then if you draw tangents from points on this line, you will be getting parallel lines. They will not be concurrent like this, is it not? All these chords of contact will be parallel to each other. That is why any line passing through the center of the circle has no pole. Okay, this is one more important point. Now, if the point P lies outside the circle, polar coincides with the chord of contact of P, we have discussed. Next point, if the pole P lies on the circle, then the polar coincides with tangent at P. Next, center of the circle has no polar, we have discussed, explained. Diameter of a circle has no pole, just discussed. The polar of a point P with respect to circle with center C will be perpendicular to CP. This point is also explained. If P is here, the polar of P will be perpendicular to CP. Next point, if the polar of a point P passes through Q, then the polar of Q automatically passes through P. In this case, the points P and Q are called conjugate points, and their diameter and the corresponding polars are called conjugate lines. Consider a point P, then its polar will be some non-intersecting line. Then if the polar passes through a point Q, then if you draw the polar of Q, it passes through P automatically, because if P is the polar of this line, if P is the pole of this line, then all the chords of contact of points on this line with respect to the circle must be concurrent at P. So, definitely this chord of contact must pass through P. This chord of contact is nothing but polar of Q. So, if the polar of P passes through Q, then the polar of Q passes through P automatically. Then the points P and Q are called conjugate points, and their polars are called conjugate lines. So, this line and this line are conjugate lines. Okay. Next, how to find the pole of a line with respect to a circle? The formula for short form of the circle x square plus y square is equal to r square is the pole of the line Lx plus My plus n is equal to 0 is given by the formula minus r square L by n minus r square m by n. Let us see how. Let us assume that the pole is P x1 y1. Let P x1 y1 be the pole. With respect to the circle, what is the polar equation of the polar? S1 is equal to 0. Equation of the polar is S1 is equal to 0, it is a formula. X1 plus y1 minus r square is equal to 0. S1 is equal to 0 for this circle will be x1 plus y1 minus r square is equal to 0. But the polar is given. So, comparing this equation and that equation, comparing with Lx plus My plus n is equal to 0. What do we get? How do we compare? x1 by L is equal to y1 by m is equal to minus r square by n, right. So, cross multiplying we get x1 is equal to minus r square by n, y1 is equal to minus r square by n. So, you need to remember this formula. for short form of the circle, formula for pole if the equation of the polar is given. Okay. Now, next point, if p x1 y1 and q x2 y2 are conjugate points with respect to a circle S is equal to 0, then the condition is S12 is equal to 0. Very simple proof. Let us take the circle as x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then if these 2 points are conjugate points, then polar of this point passes through Q. What is the polar of P? S1 is equal to 0. That is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. If it passes through Q, then substitute Q. If you substitute Q x2 y2, this becomes x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c is equal to 0, which is S12 is equal to 0 according to the notation. S12 is equal to 0. So, that is the condition for conjugate points. Okay. Moving to the next point. If the lines L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0 are conjugate lines with respect to the circle x square plus y square is equal to r square, the condition is N1 N2 is equal to r square into L1 L2 plus M1 M2. Let us prove it. If these two are conjugate lines, pole of each line lies on the other line. What is the pole of the first line? Pole of L1x plus M1y plus N1 is equal to 0 is with respect to this circle. Already we have discussed the formula, pole is given by this formula, but we have to take L1, M1, N1. So, it is minus r square L1 by N1 comma minus r square M1 by N1. This is the pole. This pole lies on the second line. So, substituting this pole in the second line, L2 into x is this minus r square L1 by N1 plus M2 into this y is minus r square M1 by N1 plus N1 is equal to 0. Multiply both sides by plus N2 plus N2 is equal to 0. Multiply both sides by N1. From the first two terms we can take minus r square common, minus r square into L1 L2 plus M1 M2, multiplying by N1, these two and N1 cancel, here you will get plus N1 N2 is equal to 0. Then taking this negative term to RHS, you will get this condition. So, you need to remember all these points thoroughly. Now, moving to the next one, inverse points. Okay. If you take a circle Consider a circle. You take a point P anywhere. I will take inside. Then what will be the polar of P? Polar of P will be some line perpendicular to AP, CP. This is the polar of P. Then if you join C and P, it will meet the polar at Q. Then this Q is called inverse point of P. Similarly, if you draw polar of Q is nothing but chord of contact, no? Then point of intersection of CQ and the polar of Q will be the point P. So, P is the inverse point of Q. Okay. So, we can simply define the inverse point of a given point P as foot of the perpendicular from the center on the polar of P. Now, these two inverse points will satisfy one important condition, that is CP into CQ will be equal to R square. Cp into Cq will be equal to R square. So, this is the property of inverse points. Now, here polar of P passes through Q, polar of Q passes through P. So, P and Q are also conjugate points. So, if P and Q are inverse points, then they are conjugate points also. Okay. Next, if P is inside, then the polar will be non-intersecting line. So, its inverse point lies outside. Similarly, if P is outside, then the polar will be chord of contact. Then what is foot of the perpendicular from the center or from the pole? This point is inverse point, no? It lies inside, is it not? So, both the inverse points cannot lie outside and both the inverse points cannot lie inside. One will be inside, another will be outside, right. Let us see the points. If C is the center, R is the radius, then the polar of P and the line through C and P intersect at Q, then P and Q are called conjugate inverse points to each other and they satisfy the property Cp into Cq is equal to R square, right. This is the diagram. Now, let us start problems. Problems on the theory discussed so far. The first question, if 4L square, this is L, minus 5M square plus 6L plus 1 is equal to 0, then show that the line Lx plus My is equal to 1 touches a fixed circle and find its center and radius. If this line touches some circle, let us assume that center of the circle is h comma k, radius is r. Okay. If the line Lx plus My is equal to 1 touches the circle x minus h whole square plus y minus k whole square is equal to r square. We have to prove it, but first we assume this line touches some circle. What is the condition? Perpendicular distance from the center is equal to radius. What is the perpendicular distance from h comma k? Mod LH plus MK minus 1 upon root L square plus m square should be equal to radius of the circle r. Cross multiplying and simplifying, cross multiplying and squaring, you will get LH plus MK minus 1 whole square is equal to r square into L square plus m square. Right. Expand it, L square H square plus m square k square plus 1 plus 2 hk lm minus 2 lh minus 2 mk, that is all, is equal to r square into L square plus m square. Right. Now, taking those two terms this side, you will get L square, coefficient of L square is h square minus r square h square minus r square into L square. Next, Lm term minus plus 2hk Lm. Next, m square term. What is the coefficient of m square? K square minus r square. So, plus k square minus r square into m square. Next, minus 2 LH minus 2 LH minus 2 MK plus 1 is equal to 0. So, this is the condition. A condition is given, based on that condition we have to prove that it touches a fixed circle. Now, if you compare this and this, suppose this condition is same as this. So, comparing these two, what will get? Constant term is directly same. So, other coefficients must be same if these two represent same equation. So, directly we can equate coefficient of L square h square minus r square is equal to 4. Next, coefficient of Lm, there is no Lm there. So, hk should be 0. hk should be 0. Next, coefficient of m square, there it is minus 5. So, k square minus r square is equal to minus 5. Okay. Next, coefficient of L is 6. So, minus 2h is equal to 6, h is equal to minus 3. Coefficient of m, there is no m there. So, k should be 0. So, all coefficients are over. So, we got fixed values of h and k. Let us check whether they satisfy the remaining conditions or not. hk is equal to 0. So, this is satisfied. These two depend on r. So, we can't tell. So, substituting h here, you will get the value of r. From this, what is r square? R square is equal to h square minus 4, that is 9 minus 4, 5. Now, you need to check the next one. K square minus r square is equal to minus 5 should be satisfied. What is k square? 0 minus r square 5 minus 5. It is satisfied. So, all the equations are consistent. Therefore, such circle exists. So, it is proved that this line touches a fixed circle. Therefore, the circle exists. Okay. So, first part is proved. Now, what is the center and radius? Center is h comma k and radius is r. So, center is equal to minus 3 comma 0 and radius is root 5. R square is 5, so r is root 5. Okay. Moving to next question. It is a very simple question, just the application of the formula which we proved today. Find the pole of the line 9x plus y minus 28 is equal to 0 with respect to the circle. Directly I gave the formula, or we proved the formula for the pole of a line with respect to short form of the circle, but here long form of the circle is given. So, what is the method? Let us assume that the pole is Px1 y1. Let the pole be Px1 comma y1. Then what is the polar with respect to the circle? Therefore, polar with respect to the circle is, formula is S1 is equal to 0, that is 2 into xx1 plus 2 into yy1 plus g into, what is g here? Minus 3 is 2g, so g is minus 3 by 2. So, minus 3 by 2 into x plus x1 plus 5 by 2 into y plus y1 minus 7 is equal to 0. Okay. Now, let us simplify, multiply both sides by 2 in order to cancel this by 2, multiplying by 2 4xx1 plus 4yy1 minus 3x minus 3x1, multiplying by 2 this 2 will cancel, plus 5y plus 5y1 minus 7 into 4 2 14 is equal to 0. Now, 4xx1 here minus 3x here. So, 4x1 minus 3 into x, 4y1 plus 5y. So, plus 4y1 plus 5 into y. Next remaining terms, minus 3x1 plus 5y1 minus 14 is equal to 0. This is the polar of Px1 y1, but polar is given. So, compare this line and this equation and solve. Comparing with 9x plus y minus 28 is equal to 0. How do you compare? Ratio of the coefficients must be same. So, 4x1 minus 3 by 9 is equal to 4y1 plus 5 by 1 is equal to minus 3x1 plus 5y1 minus 14 by minus 28. How to solve it further? Cross multiply these two. 4x1 minus 3 is equal to 4 9s are 36 y1 5 9s 54 5 9s 45 okay. Then you will get 4x1 minus 36 y1 is equal to 48. Is equal to 48. Dividing by 4, x1 minus 9y1 is equal to 12. This is one condition. Similarly, equating these two, you will get another condition. 28 into 4y1, how much? 112y1 28 into 4y1 112y1 and 28 into 5, how much? This plus another 28 40 140 minus 140, this is minus is also there now, I will cross multiply with minus also. So, minus 140 okay, is equal to minus 3x1 1 into this plus 5y1 minus 14. Now, simplify 3x1 minus 117y1 is equal to 140 minus 14, 126. I think we can divide by 3. Dividing by 3, we get x1 minus 3 3s are 9, 3 9s 27 3 9s okay, is equal to, dividing this by 3 you will get 42. Now, solving this equation and this equation, we get the answer. How to solve? Just subtract this minus that will be 30y1 is equal to this minus this minus 30. So, y1 is equal to minus 1. Substituting y1 in any one of the equation, x1 will be 3. So, the pole of this line is 3 comma minus 1. Okay. And another method is also there, you can also try. That method is, you convert the equation of the circle into the form of x minus h whole square plus y minus k whole square is equal to r square. You can convert. How? Identify the center and radius and write this equation. Now, shifting the origin to h comma k, this equation becomes capital X square plus capital Y square is equal to r square. Shifting the origin to h comma k, which is center of the circle. Now, the equation of the line will also change. Small x minus h is capital X, no? So, small x is capital X plus h. So, that equation becomes 9 into capital X plus h plus y into capital Y, plus 1 into capital Y plus k minus 28 is equal to 0. We can write it as 9 capital X plus capital Y plus 9h plus k minus 28 is equal to 0. Now, pole of this line with respect to this circle is a formula. What is that formula? Minus r square L by n comma minus r square m by n. You know r square, you know L, L is 9, m is 1, what is n? N is this whole thing. So, you will be able to get the pole, but this is not the answer because we have shifted the origin. Shifting the origin means from every point we subtract h comma k, shifting the origin to h comma k. Since we have subtracted h comma k, here this plus k plus h comma k will be the answer. You try this method. Okay. Next question. Find the locus of the poles of chords of the circle x square plus y square is equal to a square which subtend a right angle at the center. Poles of chords of the circle with respect to which subtend a right angle at the center. Pole of the chord means chord is the polar. When a chord is the polar, where will be the pole? Pole will be point of intersection of tangents drawn at the extremities of the chord. This is the pole, is it not? If chord is the polar, then the pole is point of intersection of the tangents at the extremities of the chord. Now, this chord subtends a right angle at the center. So, this angle is 90 degrees. Then what is the locus of this point? That is the given question. We can easily solve it geometrically. Okay. Draw the diagram properly such that this angle is 90 degrees. This is center. See, now this looks like 90 degrees. Now, if you draw tangents, this angle is 90, this angle is 90, this angle is 90. So, this angle must be 90. So, what is this figure? It is a square because this is radius A, this is radius A. So, this figure is a square. So, this square moves like this. If you take all chords which subtend a right angle at the center, so the square will be moving. So, the path of this point will be a concentric circle, you can easily visualize. How to get the equation of the locus? If this point is P x1 comma y1, side of the square is fixed A. So, length of the diagonal is fixed. What is C here? Center of the circle, origin. Length of the diagonal is constant, how much? A root 2. That means distance of P from the origin is A root 2 always. So, the locus of P is a circle with origin as center and radius A root 2. And already we have discussed about this locus, it is director circle. Locus of the point of intersection of perpendicular tangents, it is director circle. So, what is the answer here? X square plus y square is equal to 2a square. Okay. Next question. Find the locus of the points of intersection of tangents at the extremities of the chords. Same question. Find the locus of the point of intersection of tangents at the extremities of chords which subtend a right angle at center. Same question. Instead of asking it as a pole, locus of the pole, he is asking locus of the point of intersection of the tangents at the extremities of the chord. Same thing, this is a pole. So, moving to next question. Find the inverse point of 0, 0 with respect to the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. Suppose this is the circle, we do not know where is the origin. So, we can take origin here, O. What is the center of the circle? C minus G minus F. How will be the polar of P? The polar of the origin, it will be a line perpendicular to OC. So, this will be the polar. So, what is the inverse point? Foot of the perpendicular, this one. Suppose this is P. Then O and P are inverse points to each other. So, how to find? Let us first find the equation of the polar of the origin. Polar of 0, 0 is given by S1 is equal to 0. S1 means x1, x1 is 0, y1 is 0. So, x1 is 0, y1 is 0. So, plus g into x plus x1 means x plus 0. So, gx. Similarly, fy plus c is equal to 0. This is the equation of this line. Now, to find the inverse point, you can find the foot of the perpendicular either from the center or from the origin. Okay. So, foot of the perpendicular from 0, 0 is given by, what is the formula for foot of the perpendicular? If h, k is foot of the perpendicular, then h minus 0 by g is equal to k minus 0 by f is equal to minus of g into 0 plus f into 0 plus c. So, c by g square plus f square. So, what is the point h, k finally? That is inverse point. Inverse point of 0, 0 is cross multiplying, we get h is equal to minus gc by g square plus f square, comma minus fc by g square plus f square. Okay. Now, we are going to discuss some more theory, then we will continue the problems. That is angle between two circles. The angle between two circles of radii r1 and r2 is given by the formula cos theta is equal to d square minus r1 square minus r2 square upon 2 r1 r2. Let us prove it. Consider one circle intersected by another circle. If they intersect at A and B, the angle between the two circles is nothing but the angle between the tangents at the point of intersection of the two circles. So, at A, let us draw tangents to the two circles. Okay. I will draw again. This is another circle, they intersect at A and B. This is tangent at A to this circle. Similarly, this is tangent at A to this circle. Let C1 and C2 be the centers of the circles, and this angle is theta. We need to calculate that angle. Join C1 and C2, C1A and C2A. Okay. Let this point be P, this point be Q. This is R1, this is R2. Then angle C1AP is how much? Radius is perpendicular to the tangent. So, this is pi by 2. Similarly, angle C2AQ, that is also pi by 2. Okay. So, angle C1AQ will be pi by 2 minus theta. This total angle is pi by 2, this is theta. So, this will be pi by 2 minus theta. Similarly, angle C2AP is pi by 2 minus theta. This is pi by 2, this is theta, so this is pi by 2 minus theta. So, what is angle C1A C2? Therefore, angle C1A C2 is equal to pi by 2 minus theta plus pi by 2 minus theta. Pi by 2 minus theta plus pi by 2 minus theta. How much it is? Pi minus theta. Okay. Now, what I am going to do is, I will apply cosine rule in this triangle C1A C2. By cosine rule, this angle is given by cos pi minus theta cos of pi minus theta is equal to, cosine rule is cos of this angle is this square plus this square minus this square, that is r1 square plus r2 square minus d square by 2 r1 r2. Then cos of pi minus theta is minus cos theta. So, we get cos theta is equal to d square minus r square minus r1 square minus r2 square by 2 r1 r2. Suppose the two circles intersect orthogonally. Orthogonally means this angle is pi by 2. Then cos 90 degrees will be 0. Then we get numerator is equal to 0, d square is equal to r1 square plus r2 square. If the two circles intersect orthogonally, then d square is equal to r1 square plus r2 square. Okay. Next, the angle between the circles x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0 and x square plus y square plus 2g2x plus 2f2y plus c2, this is c1, this is c2, is equal to 0 is given by this formula. How? Here you take c1 and c2 as minus g1 minus f1, c2 as minus g2 minus f2. Then d square means you can calculate by distance formula. R1 square root over g1, R1 square is g1 square plus f1 square minus c1, R2 square is g2 square plus f2 square minus c2. If you substitute here and simplify, you are going to get this. Now, if the two circles are orthogonal to each other or they intersect orthogonally, cos theta is given by, this is cos theta. Cos theta is equal to this. If the circles intersect orthogonally, then cos 90 degrees is 0. So, this numerator will be 0. You will get the condition 2 into g1 g2 plus f1 f2 is equal to c1 plus c2. Okay. Now, there is one important thing about orthogonal circles. If two circles are orthogonal to each other, if theta is pi by 2, what happens? This angle is 0. This angle is 0. What does it mean if this angle is 0? This tangent passes through center of the circle and this tangent passes through the center of the circle. So, if two circles are orthogonal to each other, then the tangent to each circle at the point of intersection passes through the center of the other circle. Okay. That is very important point. Now, let us, and one more thing, suppose these two circles are orthogonal, then this tangent passes through the center of the circle, or radius of the circle will be the length of the tangent from C to the other circle. Length of the tangent from C to this circle will be equal to radius of this circle. That is one more important point. Now, let us solve some questions on angle between two circles. First question, find the angle between the circles x square plus y square is equal to 4 and x minus 3 whole square plus y square is equal to 9. Direct application of the formula. What are the centers? C1 is 0, 0. Center of the second circle C2 is 3, 0. So, what is D? Distance between the centers. Directly it is 3. And R1, radius of the first circle, is 2. This is R square now. Similarly, R2 is 3. Directly apply cos theta formula. Cos theta is equal to d square 9 minus R1 square 4 minus R2 square 9 by 2 R1 R2 is 12. You are getting minus 1 by 3. So, theta is equal to cos inverse minus 1 by 3. Okay. Next question. If the circles x square plus y square plus 4x plus 2y plus 1 is equal to 0 and x square plus y square plus 6x plus ky plus 2 is equal to 0 intersect orthogonally, find k. Very simple question. Just now we discussed the condition for two circles to be orthogonal to each other. What is the condition? 2 into G1 G2 plus F1 F2 is equal to C1 and C2, C1 plus C2. This is the condition for orthogonality of two circles. Substitute the values G1, G2. G1 is 2, G2 is 3, so 2 into 3, 6. F1, F2. F1 is 1, F2 is k by 2 is equal to C1 plus C2, 1 plus 2. Now simplify, this is 12 plus k is equal to 3. So k is minus 9. Okay. Next, find the equation of the circle with center 1, 2 and which cuts this circle orthogonally. Suppose this is the given circle, 1, 2 is outside the circle, you can check. Now with 1, 2 as center, I want a circle which intersects this circle orthogonally. Just now we discussed one important property of orthogonal circles. What is it? The radius of this circle which is to be orthogonal to this is going to be the length of the tangent from 1, 2 to the other circle. So calculate the length of the tangent from 1, 2 to this circle. How much? How to calculate the length of the tangent? What is the formula? Root S11. It is equal to root over, substitute 1 plus 4 plus 4 plus 4 plus 1. How much? 14. So root 14. That is the radius of the orthogonal circle. So what is the equation of the orthogonal circle? This length is also root 14. So if you take this point as center and this length as radius and draw a circle, and that will be orthogonal to this circle. So what is the equation of the orthogonal circle? X minus 1 whole square plus y minus 2 whole square is equal to r square, that is 14. Okay. Next question, find the equation of the circle which touches the line x plus y is equal to 5 at minus 2 comma 7 and cuts the circle x square plus y square plus 4x minus 6y plus 9 is equal to 0 orthogonally. Very good question. Take that line like this, touching this line at minus 2 comma 2, minus 2 comma 7. Minus 2 comma 7 is on this line. Observe, minus 2 plus 7 is equal to 5, satisfied. So take minus 2 comma 7 somewhere, touching this line at minus 2 comma 7, you can draw so many circles like this. Okay. But among them we want a circle which is orthogonal to this circle. Okay. Then what to do? Earlier in the very first class we discussed that if a circle and a line intersect, touch each other, if a line L touches a circle S, then any other circle touching both of them at the same point will be in the form of S plus lambda L is equal to 0. But where is our circle here? we can draw many circles touching this circle and the line at the same point. The equation of every circle in the family will be in the form of S plus lambda L is equal to 0. But where is our circle? That circle is nothing but this point circle. See, if a straight line passes through a point, we can say that the point straight line touches the point circle. So, I am taking point circle of minus 2 comma 7 as the circle which is touching this line. Then what is the equation of the family of lines, family of circles? S plus lambda L is equal to 0. What is S? Point circle. How do you write the equation of the point circle? X plus 2 whole square plus y minus 7 whole square is equal to 0. That is x plus 2 whole square plus y minus 7 whole square is equal to 0. So, this is S plus lambda into line is x plus y minus 5 is equal to 0. Okay. Now, let us simplify. This is x square plus y square, coefficient of x is here 4, here lambda. So, lambda plus 4 into x plus here coefficient of y is minus 14, here lambda. So, lambda minus 14 into y. Next constant term minus 5 lambda, here 4 plus 49, 4 plus 49 53, 53 minus 5 lambda. This is the circle of this family. For different values of lambda, we get different circles. Now, we want the circle which cuts this circle orthogonally. So, what to do? We have to apply the condition 2 into G1 G2 plus F1 F2 is equal to C1 plus C2. So, 2 into G1 G2, 2 into 2 into G2 is lambda plus 4 by 2 plus 2 F1 F2. 2 into F1 is minus 3 into F2 is lambda minus 14 by 2. Is equal to C1 plus C2. C1 is 9 plus C2 is 53 minus 5 lambda. Now, simplify, 2 cancels, 2 cancels, 2 lambda plus 8 minus 3 lambda plus 42 is equal to 62 minus 5 lambda. This is minus lambda. So, 4 lambda is equal to 62 minus 42 20, 20 minus 8 12. So, lambda is 3. Now, substituting lambda is equal to 3 in this equation, we get x square plus y square plus 7x 3 minus 14 minus 11y 53 minus 15, 38 is equal to 0. So, the required circle is this. Okay. Now, we are going to discuss some more theory point, that is radical axis of two circles. If you take two circles, the locus of the point whose powers with respect to two circles, the locus of the point whose powers with respect to two circles are equal is a straight line. This line is called radical axis of the two circles. Let us prove it first. The locus of such points is a straight line. Let us take the equations of the circles as x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0, and x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Now, the powers of a point with respect to the two circles are equal. Let this circle be S, this circle be S dash. Let the powers of P x1 y1 be equal. The powers of P x1 y1 with respect to the circles are equal. What is the formula for power? S11. So, S11 should be equal to S dash 11. Power of P with respect to the first circle is S11, power of P with respect to second is S dash 11. If they are equal, what is S11? x1 square plus y1 square plus 2g1x1 plus 2f1y1 plus c1 is equal to S dash 11, that is x2 square plus y2 square plus 2g2 x1, sorry, x1 square plus y1 square, x1 square plus y1 square plus 2g2 x1 plus 2f2 y1 plus c2. So, if you equate the powers, what happens? x1 square plus y1 square cancels. Then taking the remaining terms this side, you will get 2 into g1 minus g2 into x1 plus 2 into f1 minus f2 into y1 plus c1 minus c2 is equal to 0. This is the condition we got. After getting the condition, if you want the locus of P, you should replace x1 by x and y1 by y. Therefore, the locus of P is 2 into g1 minus g2 into x plus 2 into f1 minus f2 into y plus C1 minus C2 is equal to 0. What is this? This is a straight line. It is a first degree equation in x and y. So, the locus of P is a straight line. This straight line is called radical axis of these two circles. Now, observe that this is the equation of the radical axis. No? This can be obtained just by subtracting the two equations. So, what is the formula for equation of the radical axis of two circles? It is s minus s dash is equal to 0. This is the formula for equation of the radical axis. Okay. Now, we are going to close the session for today. In the next class, we are going to discuss how is the radical axis for different positions of the circles and more interesting points about the radical axis. Okay. So, we are going to close the session for now. So, we will meet in the next class. Thank you. Thanks for watching.